Hello, namaste everyone. Today we'll see in ninth standard the velocity concept. Speed and velocity are almost the same, just like distance and displacement. There is a small difference. So, how distance is a scalar quantity and displacement is a vector quantity. In a similar way, velocity is a vector quantity. So, velocity is speed defined along with the direction in which the object is moving. So speed specified in a particular direction, we can consider it as velocity. So modifying the simple definition of speed, speed is nothing but change of position with the time. So change of position of an object with the time in a particular direction is nothing but velocity. Okay, then you can also say position in a particular direction is nothing but displacement. So velocity can also be defined as the displacement of an object in unit time. So I'll put the definition of velocity in front of you so that you can have a clear information about velocity. So this is the definition. I'm going to read it out for you. So that's the definition of velocity. So velocity of a the velocity of a body is the distance traveled by it per unit time in a definite direction. So distance in a particular direction divided by time per unit time. Or we can simply say as the velocity of a body is defined as displacement per unit time. Displacement per unit time. So displacement is nothing but distance traveled in a particular direction. Okay. So we'll go for the formula displacement by time v equal to s by t. Velocity is a vector quantity and SI unit is same as that of speed, meter per second or ms power minus 1. So we have types of velocity. Uniform velocity. Uniform velocity is nothing but um, equal displacements in equal intervals of time. So that becomes a uniform velocity. Non-uniform velocity is unequal displacements in equal intervals of time as non-uniform velocity. Okay, variable velocity, we can say non-uniform velocity as variable velocity. So I'll put the two definitions in front of you. So these are the definitions. So uniform velocity, an object is said to be with uniform velocity if it covers equal displacements in equal intervals of time, however small these intervals are. And variable velocity is that in which unequal displacements in equal intervals of time. So we will go for the other definition in velocity, other type of velocity, average velocity. So average speed, you have some idea, that is nothing but total distance traveled by total time taken for average speed. So generally we calculate the average speed at the end of the journey or at the end of the trip. So after traveling certain distance, then we are going to calculate the average speed for the entire trip. Similarly, average velocity is nothing but total displacement by total time taken. This is the formula for average velocity. Let me put this here. Okay, that's the formula for average total displacement by total time taken. Now we have another case for average velocity. Let me explain you the other case here. So for this I'm going to explain you with some small situation or instance. So in that instance I will get you this. Okay. Okay. So I'll make small adjustment here. So I'm going to draw a small table here. So in this table, it's a change in velocity with the time. Time in seconds we are going to take velocity meter per second. So for 0 seconds, the object is at rest 0 meter per second. 1 second, the velocity has changed to 2 meter per second. In the second, 2 seconds, it has changed to 4 meter per second. In third second, the velocity increases to 6 meter per second. In the fourth second, the velocity increases to 8 meter per second. In the fifth second, the velocity is increased to 10 meter per second. Now, if there is a change in the velocity in a uniform way, that is for every second, the velocity increases by 2 meter per second. For every second, if the velocity increases uniformly as 2 meter per second, so in such a case, either the velocity increases uniformly or the velocity may decrease uniformly. But if there is a uniform change in the velocity, then in such a case you have another formula. The other formula is we are going to take the average of initial velocity. Generally we represent initial velocity with small u and the final velocity with capital U. Now these are the time intervals. So for this the velocity is here, that's the initial velocity, and here we are having the final velocity. So initial velocity is 0 meter per second and final velocity is 10 meter per second. So mean of this VAV, that is average velocity, equal to U plus V by 2, that is average or mean of initial and final velocities. So I am going to write 0 plus 10 by 2, which is equal to 10 by 2, that is 5 meter per second. In this case, the average velocity for 5 seconds. For this 5 seconds, the average velocity is 5 meter per second. So this is the second case of average velocity. That means if the velocity of an object changes uniformly, whether it may increase uniformly or decrease uniformly, then the average velocity is taken as the mean of the initial and final velocities. I will put the definition in front of you. Okay, this is the definition. So that's the definition, and I will put the formula in front of you. That's so there's the okay, let me read out this definition. When the velocity of a moving body is changing continuously at uniform rate, then the average velocity is given by the arithmetic mean of initial and final velocity for a given period of time. So it should change uniformly and continuously at uniform rate. Now that's the formula which I have written here. So this is the formula, initial velocity. Okay. Now we will differentiate. We'll see some points differentiating speed and velocity. So speed is distance traveled per unit time, velocity is displacement per unit time. Speed is a scalar quantity, velocity is a vector quantity. Speed is always positive for a moving body. So velocity can have the three values, again positive, negative and 0, because displacement has all the three values. Since it's a vector quantity, it depends on the direction. Since velocity is displacement by time, you will have velocity having these values, positive, negative and 0, and both are represented with V, and both have the unit meter per second. I will keep the table which is differentiating the speed and velocities. So this is a table. So this table. So that is a table which has the points of difference. So speed and velocity. Distance traveled per unit time, displacement per unit time, speed is scalar, velocity is vector, speed is always positive, velocity can be positive, negative or 0. SI unit is same for both, and both are denoted by V. Now we'll solve some numericals, which is there in textbook. You have an example here. So example 8.1 from the textbook. So I'm going to put the example and I will solve it very fast. So an object travels 16 meter in 4 seconds, and then another 16 meter in 2 seconds. What is the average speed? So we have this formula, average speed VAV is equal to total distance by total time, total distance traveled by total time taken. So here total distance is 16 meters and then another 16 meters. So total distance is 16 meter plus 16 meter, and total time, first 16 meters he is going to complete in 4 seconds, and the next 16 meters is completed in 2 seconds. So it is 32. 16 plus 16 is 32, and you have 4 plus 2 is 6. Then we can cancel with 2. 2 will go 3 times, 2 will go here, 16 to the 32. And if we divide with 16, 3, 5 is a 15 and 1. So 10, 3, 3 is 9, and it continues like that. So the average velocity is 5.33 meter per second. So that's an easy solution. So we will proceed on to the next numerical or next questions, which are there in our NCERT textbook. Distinguish between speed and velocity. We have written some points above the distinction between speed and velocity. So the next question I'm going to put. The question is, under what conditions is the magnitude of average velocity of an object is equal to the average speed? Under what conditions both are possible? So average velocity and average speed can be same if distance and displacement are same. That means an object should be traveling in a straight path along the same direction. So it is possible if the object travels along the straight line path in the same direction. So in such a case, distance and displacement are same. When distance and displacement are same, then we have the velocity and speed also the same. Okay, we'll see the next question. This is the next question. What does the odometer of a automobile measure? So odometer always measures the instantaneous speed. I'm sorry. Odometer is the distance traveled. Speedometer is the instant speed. So instantaneous speed. Odometer measurement is distance traveled here. So it's a silly question which you have been learning from your 8th standard. Distance traveled. Okay, I'll put the next question. What does the path of an object look like when it is in uniform motion? So if an object is in uniform motion, what does the path look like? So when it is in uniform motion, when we say uniform motion means equal distances in equal intervals of time. So if an object is moving in such a way, then it should always be in a straight line. So it should be a straight line path. So such a motion is uniform motion. So it can't go in any curvilinear path or some other path. Okay. Next question. So the last question I am going to solve, and then we'll go for some other examples after this. So this is the last one for this video. During an experiment, a signal from spaceship has reached the ground station. So you need to find what is the distance of the spaceship from the ground station. So here I'm going to put the question in front of you, that solution in front of you. Now you have somewhere the spaceship. Now that's the spaceship, and you have here the Earth, and this is the spaceship, and you need to find this distance. So we have the formula, distance formula. We have speed is equal to distance by time. Distance will be equal to speed into time. So here in the question, speed is given as 3 into 10 power 8 meters per second. V is equal to 3 into 10 power 8 meter per second. What is the time here? So the signal takes 5 minutes to reach the ground. So T is equal to 5 minutes. But here minutes is not SI. So we are going to convert, because we have meter per second. We'll convert 5 minutes into seconds. 5 into 60, it is 300 seconds if we have converted into seconds. Then, so put that in the formula.